Let's start the exercise questions. First question is, a visible light has some wavelength in the range of 400 nanometer to 780 nanometers. We need to calculate the range of energies of the photons of visible light. So first solution. So what do we have? We have wavelengths. Lambda 1 is 400 nanometers and it is up to 700 nanometers, 780 nanometers. So let's say lambda 2 is 780 nanometers. Now we know that the formula for energy is h nu, where nu is the frequency. Now frequency can be written as c over lambda, where c is the speed of light in vacuum and lambda is the wavelength. So from this we can easily find the energy range. So E1 will be hc over lambda 1 and E2 will be hc over lambda 2. So what we will get, so when we put the value 6.6 into 10 to the power minus 34 into 3 into 10 to the power 8 meters per second over 400 nanometer, that is 400 into 10 to the power minus 9. And similarly here 6.6 into 10 to the power minus 34 into 3 into 10 to the power 8 upon 780 nanometer, that is 10 to the power minus 9. So once we solve this, E1 will be approximately equal to 5 into 10 to the power minus 19 joules and E2 will be approximately equal to 2.55 into 10 to the power minus 19 joule. So the energy range is from 2.55 into 10 to the power minus 19 to 5 into 10 to the power minus 19. Remember, this is for wavelength 400 nanometers and this is for wavelength 780 nanometer, because more the wavelength, less is the energy. In the second question, we need to calculate the momentum of a photon of light of a wavelength 500 nanometer. So this is the second question. What do we have? We have the wavelength. Okay, wavelength is 500 nanometer or 500 into 10 to the power minus 9 meters. Now we know that wavelength can be obtained using h over p, where p is the momentum. So momentum can be obtained by h over lambda. So ultimately 6.63 into 10 to the power minus 34 over wavelength is 500 into 10 to the power minus 9. So momentum will come out to be 1.33 approximately into 10 to the power minus 27 kilogram meters per second. So this will be the wavelength for the light of wavelength. This will be the momentum for the light of wavelength 500 nanometer. So momentum will be 1.33 into 10 to the power minus 27. In question 3, an atom absorbs a photon of wavelength 500 nanometer and emits another photon of wavelength 700 nanometer. We need to find net energy absorbed by the atom in the process. So this is the third one. So wavelength first is 500 nanometers or 500 into 10 to the power minus 9 meters, and another wavelength is 700 nanometer, that is 700 into 10 to the power minus 9 meters. So what we will have is, we need to find the energy difference, E1 minus E2. So hc over lambda 1 minus hc over lambda 2. Let's put hc common, 1 over lambda 1 minus 1 over lambda 2. So energy difference will be equal to 6.63 into 10 to the power minus 34 into 3 into 10 to the power 8 over 1 over 5 into 10 to the power minus 7 minus 1 over 7 into 10 to the power minus 7. because this can be written like 5 into 10 to the power minus 7, and this can be written like 7 into 10 to the power minus 7. So once we simplify this, E1 minus E2, or the energy difference, will be approximately equal to 6.63 into 3, 1 by 5 minus 1 by 7. So once we simplify further, we obtain approximately 1.136 into 10 to the power minus 19 joules. So this is the approximate value that we get, energy difference. In question 4, we need to calculate number of photons emitted per second by 10 watt sodium vapor lamp. Assume that 60% of the energy consumed is converted into light. Wavelength is given. So this is the fourth one. So ultimately what we have power 10 watt, and energy in power is the energy per unit time. Okay, so energy in 1 second can be obtained like 10 joule. Okay, power is energy per unit time, so energy over time is 10 joule. So this is energy per unit time. So also energy, 60% of the energy is converted. So this means useful energy is how much? 60%. Useful energy is 60% of 10 joules, so it will be 6 joule. So ultimately number of photons will be energy, that is 6 joule useful energy, over 6.63 into 10 to the power minus 34 into 3 into 10 to the power 8 over 590 nanometer. So number of photons will be equal to energy over energy of one photon. Okay, so total energy over energy of one photon. So number of photons equal to approximately 176.9 into 10 to the power 17, or 1.77 into 10 to the power 19. So this many photons are there. In question 5, sun is directly overhead, and then in this situation Earth's surface receives 1.4 into 10 to the power 3 watt per meter square of sunlight's energy. Now assume that light is monochromatic with average wavelength 500 nanometer, and that no light is absorbed in between the sun and Earth surface. So the distance between Earth and sun is also given. We need to find the number of photons falling per second on each square meter of Earth's surface directly, and how many photons are there in each cubic meter near Earth's surface at any point, and how many photons does the sun emit per second. So this is the fifth one. So first part, intensity is 1.4 into 10 to the power 3 watt per meter square. Now we know that intensity is power over area, so it is given 1.4 into 10 to the power 3 watt per meter square. Now let number of photons emitted per second is equal to n. So power will be energy emitted per second, so it will be n h c over lambda equal to this will be the power, okay, energy emitted per second. So n will be intensity, or n will be lambda into power over hc. So power per unit area is this much, so power will be 1.4 into 10 to the power 3 watt, okay, for unit area, okay, for 1 meter square. So therefore when we put the values, over 6.63 and speed of light. So once we solve this, the number of photons will be 3.5 into 10 to the power 21. Now second part, here we need to find the number of photons per meter cube. So let's consider number of two parts at a distance r and r plus dr. So let's consider number of two parts at a distance r and r plus dr. So at these two locations we need to find from the source, okay. So one point is r distance from the source and another point is r plus dr distance from the source. So in time interval dt, how many photons will reach? So dv over e, this many photons will reach. So total number of photons that will be emitted, so it will be n, so n into dt, so p over lambda hc, this is n from the previous example, and dt is dr over c. Time is distance over speed. So now if we consider that the points are on a spherical shell, so then number of photons per unit volume in the shell from distance r to r plus dr will be n over 2 pi r 2 dr. And it will be equal to p lambda dr over hc square. So what we will have? We will have ch equal to p lambda over 4 pi hc square r square. Now p over 4 pi r square will be the intensity, so intensity is this much. So number of photons per meter cube per unit volume will be p intensity into wavelength over hc square. So it will come out to be 1.4 into 10 to the power 3 into 500 nanometers over 6.63 into 10 to the power minus 34 into 3 into 10 to the power 8 whole square. This square is not there, 10 to the power 8. So it will give us 1.2 into 10 to the power 13. Now the third part, number of photons will be equal to number of photons per second per meter square into area. So 3.5 into 10 to the power 21 into 4 pi r square, which is the surface area. So 3.5 into 10 to the power 21 into 4 into 3.14 into r is 1.5 into 10 to the power 11 whole square. So this will give us 9.9 into 10 to the power 44. So this will be the number of photons. In question 6, we have a parallel beam of monochromatic light of some wavelength, and it is incident on a totally reflecting plane mirror. Angle of incidence is 60 degree. Number of photons is striking the mirror per second is given. We need to calculate force exerted by the light beam on the mirror. So this is the sixth one. Lambda is given, theta is given, photons number is given. Now we know that lambda is h over p, so p will be h over lambda. So once we put the value, we will obtain 10 to the power minus 27. Now force exerted on the wall can be found out using the momentum. It will be equal to number of photons. So mv cos theta minus mv cos theta. How? So let's say this is the wall, this is the normal. So let's say light ray is coming at 60 degree angle, and obviously it will go from same angle 60 degree. So the momentum given to the wall will have two components. One component will be this and one component will be this. Similarly, one component will be this and one will be this. So this component will be, let's say this is mv, so this component will be mv cos theta, and this component will be mv sin theta. Similarly, this is going this way, so mv cos theta in the opposite direction and mv sin theta, like this. So they are in opposite direction, so because of that, final momentum minus initial momentum. So ultimately F will be 2 into 10, 1 into 10 to the power 19 into 10 to the power minus 27 divided by 2. So we will have force equal to 1 into 10 to the power minus 8 Newton. In question 7, a beam of white light is incident normally on a plane surface, absorbing 70% of the light and reflecting the remaining 30%. If incident beam carries 10 watt of power, find the force exerted by it on the surface. So unlike the previous question where 100% was reflected back, here only 30% is reflected back. So 7th one, power is 10 watt. Now obviously momentum is given by h over lambda, and momentum over time period can be put like this. So another formula that we have is of energy hc by lambda, and energy over time can be hc over lambda t. So this will be the power. So work done will be Pc over momentum into speed of light over time. So momentum over time is equal to work done over c, so it will be equal to the force, because we know that force is the rate of change of momentum. So ultimately force will be 7 over 10. This much is absorbed, and 2 into 3 over 10, this much is reflected. Why 2? Because there will be two components which will add up, okay, because of reflection. Just like here, these two components got added up and we got 2 mv cos theta. So just like that, here we also get twice, okay. So now 7 over 10 work done over speed of light as 2 into 3 by 10 work done over speed of light. So 13 over 3 into 10 to the power minus 8. So force will be 4.33 into 10 to the power minus 8 newtons. In question 8, we have a totally reflecting small plane mirror placed horizontally, faces a parallel beam of light as shown. Mass of mirror is given. Assume that there is no absorption in the lens and that 30% of the light emitted by the source goes through the lens. Find the power of the source needed to support the weight of the mirror. So there is a downward gravitational force, so we need to find the upward force. So this is the 8th one. So now mass is 20 gram. Now the weight of the mirror has to be balanced by the force exerted by the photons. So we know that momentum is h over lambda, energy will be hc over lambda, or it can be momentum into speed of light, and energy over time is the power, which will be momentum into time over momentum into speed of light over time. So rate of change of momentum is equal to power over speed of light. So 30% of light pass through the lens, so that is 70% is absorbed, or we should say 70% is reflected. So force exerted will be twice rate of change of momentum. So it will be twice power over, see again twice, because these two factors will get added up just like this here, okay. So we need to take 30% of this, so 30% also. So force is mg, weight, 30% of 2 into power over speed of light. So power will be 20 into 10 to the power minus 3 into 10 into 3 into 10 to the power 8 into 10 over 2 into 3. So it will be around 100 megawatt. So this much power will be required. In question 9, a 100 watt light bulb is placed at the center of a spherical chamber of radius 20 cm. Assume 60% of energy supplied to bulb is converted into light and that surface of the chamber is perfectly absorbing. We need to find the pressure exerted by light on the surface of the chamber. So this is the 9th one. So we have power 100 watt, radius 20 centimeter. Now 60% of the light is converted. So 60% of 100 watt will be 60 watt. Now force will be power over velocity, 60 over 3 into 10 to the power 8. So 2 into 10 to the power minus 7 Newton. We know that pressure is equal to force upon, this is power. Pressure is equal to force upon area, 2 into 10 to the power minus 7 over the area, 4 pi r square, 4 pi r square. So pressure equals 10 to the power minus 5 over 8 into 10 3.14. So the pressure will be equal to 0.039 into 10 to the power minus 5, or in other words approximately 4 into 10 to the power minus 7 Newton per meter square. This will be the pressure.